Today's lesson is on subsets. Set A is a subset of set B, expressed with this notation if every element in set A is also in set B. So the notation with a slash in it means that set A is not a subset of set B. So there is at least one element in set A that is not an element B. So here's a couple of examples. So we have two different sets. We're not talking about element of, we're talking about two separate sets. Is every element that's in the first set also in the second set? So -3, yes. 0, oh, no, 0 is not in the second set. So I can say that this is not a subset. How about the next problem? Monday, sure. Friday, oh, Friday's not in there. So this is not a subset. Okay, so all of the letters of conversation, we have to check these individually. So we have C, yes, O, N, yep, that's there, V, yeah, E, R, yes, S, yes, that's there, A, T, I, O. Looks like all of them are there. So every element that's in the first set is also in the second set. Therefore, I can say that these are subsets of one another. How about on the next problem? We've got -3 is in both sets. 3 is in both sets. Now, -1 and 1 aren't in the first set, but that's okay. This is the set of -3 and 3 is a subset of -3, 1, -1, and 3. They don't have to be equal sets, they just have to have the first set have every single element in the second set. So what if they do have the exact same elements? -3, -3, -1, -1, 1, 1, 3, 3. So they have the exact same elements. So this is still a subset because all of the elements in the first set also belong in the element of the second set. Now, this has a bigger meaning here. That means that every set is a subset of itself. So any set A is always going to be a subset of itself A, whatever that subset might be. So for our next example, we have A is the set of all X such that X is a letter in the word roof, and B is the set of all Y such that Y is a letter in the word proof. So if you're thinking about each one of these independently in roster notation, we have R, O, O, and F. For B, we have P, R, O, O, and F. And technically, you probably didn't need to write O twice. It's kind of redundant. So is A a subset of B? Well, it sure is. Every single letter in A is also in B. Okay? Is B a subset of A? Well, B is not a subset of A because B has an extra letter P that is not in A. So A can be a subset of B, but B is not necessarily a subset of A in this particular case. A proper subset. We can say that set A is a proper subset of set B, expressed this way. If set A is a subset of B and A is not equal to B. So let's determine if these are subsets or proper subsets or both. And we're going to try to use our correct notation here. So A is a subset of B. So we have 2, 2, 4, yep, that's there. 6, yep, that's there. 8, 8 is there. So we can say A is a subset of B. And we can also say that A is a proper subset, meaning the A is not equal to B because they don't have the same elements in each other. So proper subsets can only be used when we are not talking about a subset of an unequal set. So on the next example, A is the set of all X such that X is a person and X lives in Atlanta. Set B is the set of all x such that x is a person and x lives in Georgia. So we're talking about all the people that live in Atlanta and all the people that live in Georgia. Everybody lives in Atlanta, and we're talking about Atlanta, Georgia, okay? So anybody that lives in Atlanta also must live in Georgia. So is A a subset of B? Well, it sure is. Every element in A, everybody that lives in Atlanta also must live in Georgia. Is A a proper subset of B? Well, it is a proper subset because there is somebody that lives in Georgia, that is a person that lives in Georgia that does not live in Atlanta. So Atlanta is not the only city in Georgia, so therefore Atlanta is a proper subset of the set of people of Georgia. All right, let's look at the next example. We have 0 and 0, 2 and 2, 4 and 4, 6 and 6, 8 and 8. Okay, so this is a subset, but because the sets are actually equal to each other, this is not a proper subset. So to do not a proper subset, you do the subset notation and then a line through it. So the subset with the line underneath it, kind of like almost, it's a subset or equal to it, where if it's just the circle, it has to be less than it, a subset of it, not equal to it. That's why there's no line underneath it. So the next example, the set of all x such that x is a man, and the set of all x such that x is a person. So every man is a person, so we can say that is a subset. The next one, is it a proper subset? Well, sure it is, because women would belong into the set of x as a person, but they don't belong to the set of x as a man. So therefore that would be both a proper subset and a subset. So let's talk about empty or null sets. Is the empty set a subset of this set 8, 0, 6, 2, and 4? Well, the empty set is a subset because everything that's in the empty set is also in the other set. Well, because there's nothing there, like there's nothing here that has to be found in the other one. So the empty set is a subset of basically any set, okay? And so I'm gonna go ahead and say the empty set is a subset of any set. Is it a proper subset? Well, yes, because it's not equal to itself. So the empty set is a proper set of any set except the null set or the empty set. Okay. Is the empty set a subset of itself, the empty set? Sure it is. Anything that you find in the empty set, which is nothing, can also be found in the empty set, which there's nothing. So it is a subset. Is it a proper subset? Well, no, because the two sets are equal, so we're going to put a line through that one. Okay. So an empty set is always a subset of itself, but it's never a proper subset of itself. So I just want to make a note that the symbols for subset and proper subset are similar to the symbols for inequalities, or less than or equal to. So less than or equal to is like that. With it's the line underneath, which means it's allowed to be equal to, where strictly less than is like that without a line. So if that helps you remember, subsets are allowed to be equal to each other because the line underneath kind of says equal to. But proper subsets are kind of like strictly less than, where it can't be equal to it. So subsets can include equal sets, where proper sets cannot include equal sets. Similarly, less than or equal to can include equal values, like 3 is less than or equal to 3, but strictly less than cannot include equal values. That is not true. So hopefully this helps you understand the difference between subset and proper subset.